from Taiwan University, and I'm going to present our paper, QuantifyingUser satisfaction in mobile cloud gaming. And this is a joint work with Dr. Cheng-Hsin from Huang University and Dr. Cheng-Hsin from Academic Syndicate. Okay, so in this work, we implement an Android-based mobile cloud gaming client, and we conduct some extensive studies to understand how users feel about their gaming experience with mobile cloud gaming clients. Okay, so let's start from what is mobile games. I guess most of you here have a mobile device, and you may have some games installed in your device. And the statistics show that in 2011, there are about 60% of smartphone users play mobile games. And the predictions also show that by 2016, mobile games market may grow up to 16 billion of US dollars. But if you turn on your mobile device and open your mobile games, you may find that most of the games are maybe casual games, and they are not visually appealing. And we think this is because maybe a lot of limitations, such as CPU, GPU powers, memory speed, or network bandwidth battery capacity. Maybe these reasons. And maybe the control may be another problem, because the mobile device did not have a good control for you to play with complex games. So we think one possible solution to provide much rich games experience may be working with mobile cloud gaming. So what is mobile cloud gaming? In short, it is real-time gameplay using lightweight mobile clients. So the scenario is exactly the same to the traditional cloud gaming on PCs. So you will have some clients at the right side, and you will have some game servers on the right side. And then we will launch the games on our game servers, and the clients will pass their control signals from their client to the server. And all the rendering and computation will be done on the game servers, and when the rendering is finished, the render videos are streaming to the game clients. Okay, so you can choose various codecs to fit your needs. For example, we use BT8 or H.264. So this is a scenario for mobile cloud gaming. So what's the benefit of mobile cloud gaming? We think that you may have better visual quality, and you may have lower porting effort, and you may have lower battery consumption compared to you running native games on your mobile device. So with these benefits, you may attract more serious gamers because you can have more complex games on your device, and you can provide more games. So you can imagine that your PC games should be able to play directly on your mobile device. And you may have longer playing time because your mobile device just has to render the image. They do not need to compute the logic of the games. Okay. But the current solutions are mostly proprietary solutions, so you are not easy. It is not easy for you to conduct experiments with your PC games. And also, most existing mobile cloud game clients, most of existing cloud gaming devices are playing from your PC or from TV set box, and therefore it may be caused by steep development cost or high cost on gamer satisfactions. And in this work, we are going to challenge to address these two challenges. Okay, this work is also one extension of our previous project, which is called Gamingware. And the motivation of this project is that we don't have an open platform for way to experiment something with our cloud gaming platform. Although we already have a lot of cloud gaming platforms, but most of them are proprietary and closed. You have nothing to do with these closed systems. So in last year, we proposed a gaming project in the MMSys conference, and it is also the first cloud gaming platform, and it is also open source for researchers, developers, and gamers. Okay, so let me make a little bit of advertisement of our project. This is one screenshot of our project website, and you can find this is our website at gamingware.org. And our statistics also show that in the past 10 months, since our project is launched in April this year, so we already have maybe 30,000 of visitors, and from 20,000 unique visitors. Okay, and also we have a forum which has a lot of topics and posts on our forum. And for the visitors, we have a lot of visitors from all over the world, and maybe most of them come from the United States, and the number are still increasing. Okay, so my direct question just finished here. Okay, back to my slide. So, what's our contribution in this work? We have two contributions. The first is that we optimize our previous gaming anywhere client and make it able to run on the Android device. And it is the first transparent cloud gaming platform. So you should be able to run any PC games supported by our platform and streaming the content to your mobile device. And the second, we work with this platform, we conduct a lot of extensive user studies, and we want to understand how gamers feel about playing the games on PCs and on the mobile devices in terms of maybe graphic quality, smoothness, and control. Okay, so in each configuration, we will ask a lot of users to play games with various different configurations. We will diverse the resolutions, frame rate, speed rates, and network delays. And the configurations are applied to both a PC client and a mobile client. And the user have to rank it how they feel about the control, the smoothness, and the graphic quality. Okay. So I will, in my talk, I will first start from the porting effort. Okay. Currently, we only port our client to Android, and there is a lot of challenges. For example, we wish our client has a short system delay and have efficient implementation, and it is able to provide a user-friendly controller. Okay. So this is because there are already a lot of limitations on mobile devices. For example, most mobile devices access network from wireless interfaces, so the delay is much longer than you are working with wired network. And also the computing power and the battery life is also limited on mobile devices. And finally, we don't have physical input on your mobile device. You don't have buttons and joysticks, so it is much difficult to play with games on mobile devices. So in this work, we basically leverage hardware audio and video decoders and hardware renderers, which is provided by Android. So if you are working with Android, maybe version 4.1 later, you will have built-in hardware audio and video decoders, and also it has built-in OpenGL rendering. So we leverage these components to increase the performance of our gaming clients. As to the controller part, well, I have to say that we are not good controller designers, so this is out of scope of this paper. So in this paper, we just provide a simple design for the games we are playing with. So I will show some screenshots for you later. Okay, for the architecture, you can see that there is a dash line at the middle. So the components below the dash line are implemented in C or C++, which are native codes, and most of these codes are maybe from open source packages like FFmpeg or some codes from our Gaming Anywhere project. And for the component above the dash line are all implemented in Java because native Android code has to be implemented in Java. So you can see that we have 3 arrows, which is correspond to 3 network paths. The blue one is for audio streams, and the orange one is for video streams, and the green one is for controller paths. So when the client has received strings, for example, the blue one, audio strings, the user is able to choose whether this audio string is going to pass to the software decoder or pass to the hardware decoder, which is built in by Android. And for the video, it is equivalent. So when you receive video streams, you can choose to pass to FFmpeg for software decode, and then render with OpenGL. Or you can choose to pass the video stream to Android viewing video decoders, and it will render the decoded video for you. Okay, and you can find that on the top of this architecture there is a controller pack, which is our implemented controller. So the controller is a transparent overlay, and it is placed over the video rendering surface. So you can see the rendered video, and you can play the game simultaneously. Okay, this is hardware decoders, and this is software decoders. Okay, here are some screenshots. So there is demonstration for our two controllers. The left one is for Nintendo 64 game, and the right one is for the Limbo game. Okay, so we only implemented a very limited number of controllers. Okay, well, they are just to show the proof of concept implementation. Okay, for the user interface, you can see that in the left side, you have to create a profile for your game server. So you have to fill your profile name, your location, your IP address of your game server, and some minor configurations. And once you have configured a profile, you can choose the profile from the right side. Okay, the right side screen shows that our Gaming Anywhere client's main page. So you can choose your profile and choose which type of decoder you want to use. You can use a built-in decoder for which is hardware accelerated. Okay, and then you can choose which type of controller pad you want to use, and then press the connect button. So the client will connect to the server and start playing the games. Also, we provide a short video clip to see for you to see how Gaming Anywhere client works. Okay, in this demo, you can see that we have the left part and right part. In the left part, we run basically the same game. Basically, it is NDS emulator. Okay, it is NDS emulator, and we have a native one which is ported by maybe some hobbies in the internet. So this is NDS for Droid client running on Android. And for the right side, we launch the emulator, the same version on our Gaming Anywhere server, and we connect to the emulator from our Gaming Anywhere mobile client. So let's first see how the native client performs. You may hear about the sound and looking at the video quality. Okay. Oops. I have to enable the sound. Well, there's a lot of noise. You can see that the screens and the audios are not that smooth. Okay, and then we switch to the Gaming Anywhere client. Okay, you may compare the left side and right side, which is native client and our Gaming Anywhere client. And you should find that the audio is much smooth on the mobile gaming client. Okay, that's about video demo. And if you would like to try the game client, maybe we can have a try after this session. Okay, but I'm not sure if it works. But we can try if my laptop is able to run the server. Okay. How do I get to the next page? Okay. Okay. In the next part, I'm going to talk about our user studies. This is a test bed for our user studies. First, basically, we have a Gaming Anywhere server at the right side, and we have two clients. One is from PC and another from the mobile client. The PC is connected to the Gaming Anywhere server in a LAN, in the local network, and the mobile client it is also placed in the local network, but it accesses the Gaming Anywhere server through an access point. We did not conduct this study with real mobile networks like 3G or LTE, and this is because in this experiment, we just assume that you have a perfect network for launching the cloud gaming services. And in our user studies, we would like to understand how device type game generators, resolution, bitrate, frame rate, and the network delay affect user experience on mobile cloud gaming. Okay, this is our experiment settings. We use 4 games: Limbo, Mario Kart, Super Mario, Super Smash Bros. The first game is a native PC game, and the last 3 are games running on Nintendo 64 platform with emulators. And we only ask a small number of subjects, which includes 10 males and 5 female subjects between 21 and 34 years old. And we ask each of subjects to try all the configurations. We have a default configuration, which is marked in boldface font. And so each subject has to play on PC first and then on mobile. The order of these configurations are randomized, so they do not know which configuration they are working with. And after each gameplay, they have to provide their opinion score, which ranks from 1 to 5 on graphics, smoothness, and control. And we collect these numbers and make some basic statistics to show what is the factor to affect the user's experience on mobile cloud gaming. Okay, this is a short summary of our results. And you can find that for the control part, the PC is obviously outperforming mobile client, and it has much higher score. And for the smoothness, they have similar scores. And for the graphics, well, it is also a surprise to me that the mobile client has much better graphics than on PCs. And we think about why we get such a strange result, and we finally concluded that maybe first, the subjects may have low expectation on mobile device. They may feel that the graphics quality on mobile device is not that good. So when they are playing with the mobile cloud gaming, they feel that this is much better than their expectation. So they give higher scores. And the second is that because the mobile device has a relatively smaller screen, so maybe the graphics imperfection is not visible on the mobile device's screen. Okay, so our conclusion is that the satisfaction level are based on the observed flows than the absolute quality. Okay, and we have also other statistics on the rankings, and the features are only shown in paper. I did not put them here, but for the impact on different game genres, we find that subjectives are more sensitive to graphics qualities in Limbo than Mario Kart. You may not have experience with these 2 types of game. Basically, Mario Kart is a racing game, and Limbo is an adventure game, and it is a 2D score-based game. So when users are playing with Mario Kart, it is a fast-paced racing game, so you may not have energy to notice the graphics quality when you are playing a game. But when you are playing with Limbo, you have a lot of time to inspect every pixel in the screen, so it is relatively easy to find the graphic imperfections in the rendered image. And for the second one, subjects are less sensitive to controlling platform games, for example, Limbo and Super Mario, than in the fighting games, like Super Smash Bros. And the Mario Kart game. This is similar to the first point. This is because that when you are playing with Super Smash Bros. Or Mario Kart, you have to face the AI components in the gaming. So, because you will not have, you have busy with your controls, and I guess it is not enough for you to play with such a fast-paced game with difficult to use control. And gamers have enough time to prepare in a slow-paced game like platform games like Limbo and Super Mario. Okay. As to different considerations, you can also find that first, the graphic quality is based on our statistics, is affected by bitrate and frame rate. And we also find that resolution has no impact on the graphics quality. So even you provide lower resolution or higher resolution, it does not affect the score on mobile clients. So we suspect that first, games are not too complex. Maybe that is because our game is very simple game. And second, that is that mobile clients always upscale the video. We have a Full HD screen on a mobile device, but the game resolution is much smaller than the physical resolution. As to the smoothness, we observed that smoothness is affected by network delay, frame rate, and bitrate. And we also suspect that low graphics quality leads to low MMSys score, but we're not sure, so maybe we will do this in our future work. And finally, the control part is only affected by the client type, so it will have higher scores on PC and lower scores on your mobile devices. Okay, so let me make a brief conclusion. Basically, in this work, we present the optimized Android Gaming Anywhere client and conduct extensive mobile cloud gaming user studies with our implement client. And we observe the three main insights, which includes the first is gamers are more satisfied with graphic qualities on mobile devices, and the bitrate, frame rate, and network delay affect graphics or smooth qualities on the most. And finally, the control quality is only affected by client type. Okay. Okay, that's all. So, any questions?
Any questions? So, I had a question. In your experiments, you had network delay as one of the variables. What did you do with the delay jitter in those scenarios?
We don't have.
That seems to be like the bigger issue in a lot of these things, right? Because
Yes.
delay jitters all over the place, which I assume is higher with the 300 millisecond. Seems like that would cause issues. So.
Yes, but we don't have a parameter for jitters. Maybe we can consider that in our future studies.
So were all the packets delivered, so when you're doing the 300 millisecond, they were all just delivered as they were arriving?
Basically, we add a fixed delay to the traffic. So even if there is a jitter, it should be still there. We don't affect the jitter part. But all the packets are delayed with our fixed delays into the network flows.
But this was all a local
Yes,
area network, right? So
yes.
it would probably just have no, it wouldn't experience delay jitter because you're just the.
I guess it is difficult to observe jitters in our local network.
Yeah.
I guess, but actually we have another project and we are planning to use crowdsourcing technologies to see if such a service is running on internet, if we can observe some more interesting observations when the delay and the jitters are different. But in our local experiment, I think it is not difficult. It is difficult to see jitters in our network.
So clarification for the Nintendo 64 emulator, right? What's the resolution that it simulates? I mean, what is the image that it creates? Because you have like 180 by 960, right? What is the resolution of the game itself?
The resolution is the game running on the PC side. Okay. So, for example, if we are working with the emulator, you can configure the rendering resolution at the resolution you want. So the output resolution of the emulator is the 3 we use here.
The game itself is loaded.
I think he's talking about the actual game itself, like this, right? This is a sprite-based game, so there's like n number of pixels per Mario, right?
Yeah.
And so it doesn't matter what you set the resolution to, Mario is going to be 16 by 16 pixels or something, right?
Original.
Yeah, the original, right?
I guess it's maybe the first one, I guess. I'm not sure, but I guess it should be the first one. It might be the first one. I'm not sure, but
It's been many years since I played that, so I don't know. It's not to date myself.
it's Nintendo 64. It's Nintendo 64 emulator, so it should have much higher resolution than I guess that when you play.
So I think the original game is like 320 by 240 or something.
Well, the thing is, right, basically, all this stuff is, driven by the sprite size, right? So you have a sprite size for the background. It doesn't matter that if you have a much larger display, it's just going to render, let's say it's 320 by 240, and then it'll just scale it up because the original game was some smaller resolution.
Yeah, so we might have to try more complex games.
Yeah.
So then it may translate to the different qualities you saw, right? Like on a PC or something, you're having these 1 pixel show up as big or something.
So yes.
So, do commercial cloud gaming providers give out any information, or do you know of any commercial providers that have any information on the quality of experience?
We are not sure because some of the traffic are encrypted and we can only passively monitor the resolution. And the most information we can know is the resolution, but we don't know the parameter of how to generate those videos.
They seem to go out of business. Why?
So I have a question regarding your subjects that you used. Are they, were they random students that you took off the campus, or were they students who are involved with gaming research? I'm just trying to figure out whether the subject that you used might have had some bias with, because I think there was a study at NetGames which said if you had people who had were working on gaming research, they would give better scores than people who, have no skin in the game, sort of. So I was just wondering how you selected your subjects for yourself.
Well, I'm not able to answer this question right now because I don't have statistics. But I guess most of the members are from our lab, so.
Okay. That's what I suspected, yeah.
You have the same problem with video quality assessment.
Yeah.
I teach undergraduates, once you teach them where the things are bad, then everything uniformly becomes worse because they're attuned to the.
So that's why we are going to working with crowdsourcing solutions. So we hope that we can attract random audience to play this system.
Okay. Thank you very much.
Okay, thank you.